So good evening and welcome to this session. So already we have covered 4 sessions. We are into the 5th session. So we covered some topics in civil engineering, like the general concepts in structural design. Also the estimation, the ERP system and some softwares also. I hope it was useful to you. And I would definitely like to have an interactive session now. So already we have covered some topics, and I also know you are in the 3rd year, that is in the 5th semester. So you might have covered the mechanics of structures and one paper in structural analysis. So you know what are the types of supports you are using in civil engineering for different elements. You also are aware of the various loads, like a concentrator load or a UDL or inclined loads or lateral loads. So these things also you might be aware of, and you might be aware of the responses which the members will be giving for the actions which will be acting on these members. So these things you are aware of, I hope. So you should have this background to know about the design, how we are designing. And I'm actually taking a very light session today. So it's the basics of structural design, the art of structural design, how you go about the structural design. So can you just name some of the structural elements you have come across? Yeah, yes. Can you unmute and tell me some structural elements which you've come across in your analysis? Please unmute and tell me.
Ma'am, I think you can. Okay, continue.
Yeah, please.
We came across a cantilever beam, simply supported beam.
Excellent. So it is beams. Basically, you've come across beams. Have you studied about frames, portal frame, trusses?
Ma'am, we came across trusses.
Trusses, yes. I think in 3rd semester you might have studied the forces coming on truss members, right?
Yes, ma'am.
Yes. So you have in structural analysis 1, I think you might have studied about the portal frames also. Moment distribution method, continuous beams. Yes?
Yes,
No, ma'am.
Yeah, no. No. So portal frames, yes?
No, ma'am. It's actually in the 5th module, so we need to reach there.
You've not reached. So have you come, what about continuous beams? No?
No,
Fixed
ma'am.
beams? Fixed beams? Okay, these are some of the elements which you come across in a structure. Okay, so please understand these things are important in the coming semesters and in your career also. So when you're studying, see the applications of this members. So if you take a beam, that beam will be there in a structure. So what are the types of loads coming onto the beam? You know, what is the type of the support which will be there for the beams? You know, there will be simple supports. It will be a cantilever where one end is fixed, the other end is free, and there will be fixed beams. There will be continuous beam. There will be propped cantilevers. All these conditions will be there in structures. So these are structural elements. Now, why you call that as a structural element? Any idea? Why you call these as structural elements? Anybody can answer? Aishwarya or anybody can answer? Because Sajana is answering already. Any idea why you call that as a structural element, or you know what is a structural element or and a non-structural element? No idea. So structural element means it will be able to resist the load acting onto that. Okay, it will respond to the load. It will resist the load. And how it is resisting? By deforming. It will deform. If you take any beam, okay, in that beam, if you put a concentrated load in the middle, what will happen? It will deflect, isn't it? It will bend. So that is the way it is resisting that particular load. So when it is resisting, what is happening to that beam? The stresses are developed, isn't it? What kind of stresses are developed? For example, you take a simply supported beam, which is subjected to a concentrated load in the middle. What will happen? How do you analyze it? What exactly you do in the analysis of a simply supported beam having a central load in the middle? What exactly you find out? First, you find out the reactions, isn't it? Yes or no?
Yes.
Yes. So after finding out the the reactions, you then go on to find out the bending moment at various sections, and you draw the bending moment diagram and the shear force diagram. This you studied in the third semester. So what exactly is the bending moment diagram and the shear force diagram? Bending moment is the moment at each section, isn't it? Because of the load acting onto that. So what exactly is happening there? The beam is deflecting and it is trying to resist the load. So when it is resisting the load, the stresses are developed in the beam. So what kind of stresses are developed? When it is bending, you know how it is bending? How it is deflecting? It is deflecting downwards. When it is a simply supported beam, it will deflect downward. So when it is deflecting downwards, the top surface is subjected to compression and the bottom surface is subjected to tension. You've studied this. So because of those stresses, a stress resultant will come. Okay, that stress resultant is the bending moment. So basically, the bending moment, shear force, axial force, all these are stress resultants. The stress is developed, and this because of this stress developed, there will be a resultant for the stresses. So those are the bending moment, shear force, and axial force. Okay, and once you know that this is the bending moment, then you have to find out what kind of or what section, what proportion of section you have to give to resist that. That is called design. Okay, this is in general I am saying. So you have studied what is a beam, what are the types of supports, and for different kinds of supports, the behavior is different. Okay, and because of that behavior, the stresses developed will be different. For example, for a cantilever beam, when it is bending, what is the kind of stress at top? What kind of stress is developed at top?
Tension.
Tension. Whereas in a simply supported beam, what kind of stress is developed at top?
Compression.
Compression. Excellent. So depending upon the support condition, the behavior of the element, structural element changes. Okay, so the structural element is an element which will resist the load, and also it will transfer the load to the supports. Whereas a non-structural element, it will not be able to resist the load. So that is the difference between a non-structural element and a structural element. Can you give me an example of a non-structural element in a building? Or can you tell me structural elements in a building now? Now you know what is a structural element. It should be able to resist the load. Any idea about the structure? Beam is a structure. Excellent. Only Sajna is answering. Yeah, yes, Pranav.
Column.
Column. Excellent. Column, slabs.
Slab.
Okay. Excellent. Excellent. So the even foundation, these are all structural elements Why they are called structural elements? Because they are able to resist the loads and transfer the loads to the supports. That is why they are called structural elements. Okay, these are in general, you should know about a structure. So coming back to my presentation, just tell me if it is not visible, please give a shout. I'll just do the needful. Okay. Now, before starting this, you just have a prelude about certain things like if you want to know and understand any building or a structure, you require certain things. What are the requirements? You should have an intuitive ability to read and feel it as a structural object. Okay, so you have to look at the structure and you should have a feeling for that structure. What do you mean by feeling? Because you should know how it is going to behave. Okay, when you meet a stranger, you can actually, when you are approaching that stranger, you will know how he is going to react to your question. You will have some expectation, isn't it? Similarly, you should have an expectation of how the structure is going to behave. That feeling you should have. Okay. Then you should have the skill to identify the functional requirement. So if the building is an educational building, you should know that it should have a passage. Okay, that building should have a passage for the students to walk through that passage to enter the classroom. It should have a height more than the height of a residential building. Okay, and the classroom size should be a minimum depending upon the caudal provisions. So, for example, if you take a bridge, what is the functional requirement for a bridge? It should be able to, there should be two-lane traffic, so enough width should be there. Okay, in a supporting condition, support should be very strong. You should know what should be the span to cross. If it is crossing a river, what should be the span? So those requirements you should identify. Also, you should have an ability to distinguish between the structural and non-structural parts of the building or the structure. So you know what is a structural and non-structural parts. Now coming to the perspective, when actually I should tell you the story of the elephant and four blind people, how they explained or they described the elephant. You know the story? Yes? Nobody knows? The
No,
four
miss.
blind. Yeah? No? Nobody knows? So it is old story, is it? So the story is like this. I'll just say one blind person. So the blind, they are blind. They don't know what is an elephant. Okay. So they'll feel the elephant and then they'll say that the elephant is like this. So the first person, he'll touch the trunk and say it is a long funnel-like thing. Okay. So it is the perspective. It is, they are feeling it and they are telling, oh, this is the elephant, because they can't see it. So even if people are seeing it, people have different perspectives. Okay. So the perspectives, coming to the perspectives, if you see this, can you recognize, identify this structure? This is the needle tower, which is in Seattle. So if you see this structure, a structural engineer will see this structure like this. So there is a mass at the top. So here there is a mass. This mass is there and it is supported by these elements, like a column is coming and there are cross members here, here and here. So you're seeing that, and there will be some joints here. In that joints, the load will be transferred. This is a structural engineer's perspective when he sees this structure. Whereas if you see, I've just taken two engineers only. A geotechnical engineer will see this as a structure, a mass, which is supported at top, and it will transfer that load due to this weight and the lateral load acting onto this, the foundation, and how the soil will react to this. That is a concern of a geotechnical engineer. So different people or different engineers see the same structure in a different way. So this is what you have to see. But of course, nowadays, these are all together. So a structural engineer will also have to design the foundation depending upon what is the soil condition. Now, why we design any structure? Any answer? Why to design any structure? Yes.
For fulfilling our
For what? I didn't hear.
for meet our needs, for
To
fulfilling our
meet our,
requirements.
excellent, to meet our needs. Yes. Any other thing? Others? Why we design? Others, can you
To
unmute?
resist load,
Huh?
to resist load without
To
failure.
resist loads. So you have to know that the loads are coming. How to proportion it? You have to proportion the member. Yes. So there are different reasons for designing a structure. Okay. So these are some of the reasons why we design a structure. So to ensure that the structure is fit for the purpose for which it is designed, and the structure should be safe, it should be economical and durable, it should be safe in fabrication and transport the elements to the site. This is true for steel structure and handling and erection and future maintenance, and sometimes you have to deconstruct or modify the structure. So we should be able to do that. And finally, if you want to demolish it, that demolition should be easier. And the most important thing, it should be a sustainable construction. Okay. So what is a sustainable construction? What is sustainability? What is sustainability? What is sustainable construction? A construction which will meet the needs of today or this generation, and at the same time, it will not hamper the needs of the future generation. That is a sustainable construction. And also, nowadays, the construction materials are very scarce. So if you have to use the material, you have to use such a material that you will be able to recycle it and reuse it. This is very important in this sustainable era. Okay. And this is required for design. So when you have to design, you should also know what are the forces acting on the structure. So what are the forces acting on the structure? The forces induced by gravity is there. So the gravity loads are the dead loads, which are permanent in nature, which means they are the self weight, and some attachment which is permanent in nature. Like if you are designing educational building, the furniture, the desk and bench, they'll be permanent in nature in the classroom. So it can be considered as a dead load. And there will be live loads, which are also called imposed loads. And there will be moving loads. You might have studied moving loads in structural analysis. So the moving loads comes into importance when you are designing a bridge. So in a bridge, the loads are moving, isn't it? The vehicles are moving. So in the vehicles, the loads are transferred through how it is transferred? Through the tires. So if it is a four-wheeled vehicle, that means four tires will be there. So the weight of the vehicle will be transferred through those tires, and it is moving continuously. So when the load is at a particular position, the stresses will be different, and that stress will be varying again because the loads are moving. That is very interesting to study the moving load, the stresses induced in the structural members when the loads are moving. Okay. And there are imposed loads like live loads. When the people are there in a room, it is a live load because the people are not there always in the room. So it is considered as a live load. Okay. Then there will be wind and earthquake loads, which are lateral loads. So more than the gravity loads, wind loads and earthquake, the lateral loads will create more problems for any structure. I'll explain that in the when we go deep into the session. And there will be loads due to rain and snow. There will be fluid pressures which you have to consider. And there will be loads, other loads like machine loads. When the machines are working in a structure, in a floor, there will be loads, the vibrations induced in the structural elements. So those elements should resist those vibrations also. So those loads also you have to consider. So it all depends upon what is the type of structure you're designing. This is the pictorial representation of the loads coming onto a structure. So dead loads are there. You can see the dead loads here coming onto the roof. In the roof itself, we have live loads like snow loads, and the walls and floor loads are considered as dead loads, and there are live loads which is due to the furniture and people, and there are loads collected in water, hydrostatic pressure insert or induced in on the as lateral loads in the walls, and there will be hydrostatic pressure in because of the water table in the soil, and there will be soil pressure which will be acting as a lateral loads. Okay, this you'll be studying in your, I think, 5th and 6th semesters. I think some of this you might have studied in geotechnical engineering also. Geotechnical engineering is covered already in the 4th semester.
Yes, ma'am.
Yes. Yes. So you must be knowing about what is water table and what is a hydrostatic pressure, which will be exerted on the walls. These things you must be knowing now. So these are the loads which is coming onto a structure. Now, you take all these loads into consideration while designing. But will it be safe? Do you think the structure will be safe if you design for all this? This structure is going to be safe. Can you say 100% the structure will be safe? Yes. It is not possible for us to say, okay, I have designed this structure for all the combinations of loads, the lateral loads, the wind loads, the earthquake loads. I have taken all this into consideration. Suppose the water table is up, I have taken that pressure into consideration. So I've taken all these combinations and designed the structure. Still, can we say the structure is safe for all conditions? No, we cannot say, because there are certain uncertainties which will affect the safety of a structure. Now let us see what are these uncertainties. One is the loading uncertainty. Another is the material strength. We assume certain strength for the material. You may not get that strength, even though you take a lot of factor of safety while designing, which you might be studying in this current semester. What is the factor of safety you take for the materials? And the structural dimensions, this is especially true for structural steel buildings. You fabricate in the shop a beam and you bring it to the site, and when you try to connect it, you will see that the length is shorter or longer. So you have to do some manipulation there and then do the connections. And the behavior of the structure under various loads. There will be design errors. And there will be natural disasters. There are man-made disasters and natural disasters also. So these are the uncertainties which will affect the safety of a structure, even though you design for all the load combinations. I just covered some of the topics here in the loading uncertainty. Have you recognized this structure? This is the World Trade Center. This attack by the terrorist in 2004, this happened. Is it in 2004, 2000? It is in 2011, isn't it? When was this? Any idea?
2001.
2001. So this happened then, and we just cannot design for this force, can we? So this is a loading uncertainty which is beyond our control. Okay, so this happened, and then this earthquake, even though how many have you referred 1893, IS 1893? 1893 deals with earthquake forces. Okay, So that is for India. And we have 5 zones. The severest is zone 5. Even if you design for zone 5, the lateral loads coming for because of the zone 5 actions, sometimes what happens is the intensity of the earthquake will be so different than what we have designed. The whole structure will not be able to resist it and it will just collapse. And hurricanes, this is also another type of natural calamity which comes, and you will not be able to design for this also. And another aspect is the tsunami. So I've taken some cases here just to show. I'll it is further given. I'll show you that what is happening because of this earthquake. That is about loading uncertainty. This is material uncertainty. We don't expect any material to behave like this. This is the buckling of a reinforcement in a reinforced concrete column. We don't expect it to buckle like this, but sometimes it happens. We say that this is strong and there is enough lateral ties given. But sometimes what happens, the lateral ties which we had given will not have that much strength and it will just, the load, it will not be able to resist and this will directly come to this and this will buckle. So this can cause a catastrophic failure of the whole structure. Okay. Again, this is another failure because the material uncertainty, the quality of the material is poor. So such cases will come even though we design for all these conditions. We take into consideration the factor of safety and everything, but this can happen. Then there will be design errors. So you design a structure in the design office and there will be 2 to 3 checkings in the design office. And then you make a drawing and given to the construction engineer at the site and they will also check it. But still there can be some errors which will escape everybody's eye. Such mistakes can happen, and those are called design errors. This is one such wrong detailing of the reinforcement, which actually happened, detailed like this, and the whole staircase collapsed, even while constructing itself. And this is another web crippling happened because there was no web stiffener given to this. Again, a design error. Okay, this of course can be corrected if you thoroughly check your design 2 to 3 times or by 2 to 3 people. That is why we say always when you design, you give that design to some other person to check it. Okay, they will be able to find. Even with 2 to 3 checkings, this can happen, but it should not happen as we are responsible structural engineers. This is another interesting, case, the behavior uncertainty. This is Tacoma Narrows. I would request you to see this behavior. This is available in the internet. You just search for Tacoma Narrows. So this is a bridge, again, a suspension bridge. This was designed for, when you design for suspension bridge, you have to design for dynamic condition also because wind load will be acting. So when the wind load is acting, there is a natural frequency for this bridge, suspension bridge, and that natural frequency should not match with the frequency of the external loads, which is a wind load. And if the natural frequency and the external load frequency matches, what will happen? What will happen?
Failure.
Why it will fail? What happens when the frequencies match?
Resonance.
Resonance. Excellent, excellent. Resonance. Okay. So when resonance happens, what happens? The displacement will be maximum. Isn't it? You might have seen that folk, you might have seen that resonance happening and how it is vibrating. So it vibrates and the displacement will be maximum and the structure will not be able to take that much deformation. So the whole structure collapse. This is what happened exactly in this Tacoma Narrows also. And some people lost their lives also. Please Google it and see. It is very, very interesting case. Okay. So you'll be able to see how it is. Somebody was able to take that, this resonance happening and the whole failure. It is available in the internet. Please Google it and just see that. Okay, this is the behavioral uncertainty. We never expect the structure to have a resonance with the external force frequency. We always, the code says that it should be around 20 to 25% away from that natural frequency, the resonant frequency or the frequency of the external force. But it can happen. This is beyond our control sometimes. And there are natural disasters like earthquake, tsunami, and floods, wildfire, volcano eruption. So it is very difficult for us to design for these forces also. So I'll just show you some earthquake destruction. This is what is happening in earthquake. The ground will have an acceleration because the ground moves, the structure also moves. So you can see the swing in which the swinging of the structure. If it is not able to take that much, flexibility, then the whole structure will collapse. So you have to design for that. Okay, that is why while designing, we design that as a ductile failure. Okay, so which you will be studying in the current semester. What is a ductile design? Okay, ductile failure and brittle failure. Brittle failure means it will suddenly fail. Ductile failure means it is a gradual failure. It will fail, but the failure will be gradual. So what is the advantage? You will get enough time or you will get enough warning. You will be able to escape the place. That is only advantage. Okay. So I want you to see this landslides. Even though you design for this landslides will affect the other structure, which we have not designed for it. This is the liquefaction. I have a very interesting case of liquefaction which happened in the year 2018 in Indonesia. I have the video of that. I'll show you. This is because of the ground movement due to the earthquake. The whole structure collapsed. Okay. This is the video which I was telling you. Just observe this, what happens to
This is
this.
Dabu 7. I want to share with you guys here just a quick.
You just see how this is Indonesia, and this happened in 2018. There was an earthquake. Because of the earthquake, there was liquefaction of the soil. See how the whole massive destruction happened. Can you design for this? The whole thing is moving, the whole structure. So for such forces, we'll not be able to design. Okay, this can happen. Another case is the tsunami. Again, can see what happened. This was in 2004 in India. This happened.
Entire cities flooded.
I've taken
Entire
this
towns inundated.
this video especially because I wanted to know the intensity of the load, the magnitude of the load because of the tsunami. See how the whole thing is washed away.
Tsunamis can strike with little warning because they're usually triggered by waves. In the deep ocean, a typical tsunami wave is barely noticeable and poses little threat. But the waves can spread out thousands of miles, rolling across the ocean at speeds up to 600 miles per hour. As the rolling water reaches the shoreline, the wave's friction against the shallower floor slows it down and raises its height. By the time it reaches the shore, the wave can be as tall as 100 feet. Unlike ordinary waves, a tsunami wave doesn't crest and break. Instead, it moves forward like a solid wall of water that crashes over the coastline, obliterating almost everything in its path. And just when you think the danger is over, it recedes, dragging everything by a tsunami that claimed nearly 16,000 lives. But the deadliest tsunami in history is believed to be the Indian Ocean tsunami of 2004. The U.S. Geological Survey estimated that tsunami released the energy equivalent of 23,000 Hiroshima-type atomic bombs.
Just imagine.
An earthquake created an estimated 600-mile rupture on the ocean floor. This caused the tsunami to form and then travel at the speed of a jetliner, reaching over 11 countries, traveling over 3,000 miles, killing more than 220,000 people. Because they can strike so quickly with such deadly force, tsunami warning centers around the globe are on.
So the only consolation is that there is technology in that. Using that technology, we can predict, okay, tsunami or earthquake will happen of this scale. So we can vacate people from that place. That is the only thing we can do. We will not be able to design for such forces. Okay. So if it is a natural destructive force, then definitely we can predict. But if it is a man-made destruction or destructive force, like a terrorist attack, we will not be able to predict. That is the only problem with between the two, the difference between the two. Now, next is the type of structural system. Now, what is a structural system? Structural system is nothing but an arrangement or assembling or construction of a structural element. You know what is a structural element, okay? Which will be able to resist the load and transfer the reactions safely to the ground, okay? And the stresses developed in the structural element will be within the limits. So the structural element will not fail. It will be able to resist it. At the same time, it will be able to transfer the loads to the ground also, or to the foundation also. That is called the structural system. Okay. Now there are different types of structural system. This is a typical structural system where this will transfer the load to the foundation. Can you identify this structural system? It is nothing but a load-bearing structure. Okay, so load-bearing structural system it is. You can see that this is transferred from the slab through the wall, then through this to the foundation. So it is all load-bearing wall. So load-bearing structure. Can you identify this structural system? Yes. Anybody? It is a framed structure. Yes, it is a framed structure. Excellent. Okay. So in framed structure, what happens is you have definite frames. Okay. Through the frames, the load will be transferred to the foundation and to the soil. So from slabs, it will transfer to secondary beams, and from secondary beams to the primary beams, from primary beams to the columns, and from columns to the foundation, and finally to the soil. So that is how in the framed structure, the load is transferred. So can you identify this? This is again a braced or framed steel structure. Okay, this is again, you might have seen these frames in your structural analysis. If you have not seen it, you will be studying this. So you can immediately identify that such frames are there in buildings, structural steel buildings. So you need to study the behavior of or the stresses developed in those frames because of the external forces acting on that particular frame. So the loads can be downward loads. There can be lateral loads also. Okay. This is, can you see this structural system? These are shell structures. Okay, you can see the shell. These are pre-engineered structures. This is very common nowadays and people prefer this. Pre-engineered means you fabricate it in the shop and you then transport it to the site and then you just assemble it to make the structure. I have seen it happening in India, when I was in Sydney also, I've seen they are using many types of material. Can you name some of the materials used in this pre-engineered structures? Anybody? Have you heard of gypsum board? Developed by IIT Madras. Even FACT was manufacturing it. Gypsum board. It is actually developed from the waste material. So all these walls, they'll be, I didn't include some pictures of that. There are many pictures available in the internet. You can Google it. It is called gypsum boards. So all these walls will be constructed of gypsum boards. So these are all cut into standard sizes. The only disadvantage is you cannot have any dimension you want for the buildings. Like they all will be standard size. So it will be the standard size. Walls will be cut with openings for doors, windows, and ventilators. So it will be cut in the shop only, and then it will be transported and then assembled. Within 2 to 3 days, the whole building will be ready for for the use for which it is constructed. So many places they are following it nowadays. Even in India, many places using gypsum board. Many constructions are going on. You can do pre-engineered structures using precast members, steel members, even glass shades. You can use it. So many facades you can use. You can make use of those glass panels also. So it's a very recent development, and it is in India. In India, it is a very recent development, and it is now being used widely. Now, these are mass structures like dams or pyramids and tuned mass damper, which is used for earthquake resistant design. Now, the challenge is identification of the typical structural system. You know what is a structural system? We have seen the different types of structural system. Now, you have to choose a typical structural system for any type of project. So you see the project and how you choose that structural system for a particular project. What all things you have to consider? Can you tell me some of the aspects you have to take into consideration while deciding on a structural system? Can you tell me? Oh, it is already 9 o'clock. Sorry. Some of the aspects are the economy, the location, the loading condition, and the functionality. So all these things you have to consider, okay? And this is a typical structural system. Can you see which is the structural system which is transferring the load? The arch, okay? And here also it's a typical arch which is transferring along with the girder and columns also. This is a portal frame which is transferring the load. This is truss. This you can easily say it is a framed structure. You can easily analyze it. This is again a frame. This is a folded plate and some girders which are used. Folded plates is again a very interesting structural element it is the best example is if you take a paper and just put a pencil on top of that paper, you hold it and put a paper on top of that, will it remain there? No, it will just deflect. Okay, it will not be able to resist it. But if you just fold the paper and keep the pencil or pen, then it will be able to resist it, or it will be able to hold that pencil or pen on that paper. So the thing is, when you fold it, it will get more strength. Okay. So that is the advantage of folded plate. The simple way of understanding a folded plate is that This is again a saddle shell. In a saddle shell, you will have a concave surface and a convex surface in the same shell. So coming to the design process, in the phase one, you should know the client's needs. So what are their requirements functionally, aesthetically, and based on their budget. And then you have to develop the project concept. Okay. So the possible layout you have to see, and the approximate analysis you have to do for preliminary member sizing. Then you have to select the most desirable structural system, based on the safety, economy, maintenance, and other aspects. And then you design the individual system. Once you design the structural system, decide on the structural system, then you have to decide. Okay. So when you are designing, you have to see the stability. Then you have to see, do the structural analysis. After the structural analysis, you will get the stress resultants, that is bending moment, shear force and all. Then you decide. Okay. Then you have to design each element. That means you have to proportion it. If it is a rectangular element or rectangular beam, what should be its depth and what should be its width. Okay, it depends upon the supporting condition, it depends upon the span. Many aspects are there. I'll deal with those things in some other class. And then you have to do the connection design. Okay. And when you are doing the structural stability, definitely you have to check for sliding and overturning because of the lateral forces acting on that. So in the structural analysis and element design, you have to see the strength criteria. So what is the strength criteria? Ability to withstand the given stress without failure. Okay, depends on the type of material and the type of force. The failure can be a tension failure, a compression failure, or a shear failure. Okay, so these are the types of failure which can happen. So I've taken some pictures also for you to see the tension failure. You can see the beam which is bending, and there is a, because it is simply supported beam, tension at bottom, you can see the failure. This is buckling, a compression failure, and this is the shear, the relative movement. You can see the shear failure. Here also the diagonal shear. This is a concrete and this is steel. So another aspect which you have to see is the stiffness or the rigidity. It is the property related to the deformation. As I told you, in lateral load resistance, it should be more flexible. Otherwise, only if the gravity loads are there, then you can design a very stiff structure. And systems required for structural stability, you can see primary beams. These are the primary beams and secondary beams. Okay. And then you have the horizontal floor plate, which are the floor slabs, and you have vertical walls. So these all will form the structural stability system. Okay. So as conclusion, I'll say when you are doing the structural analysis and design process, first you have to see the conceptual design. So depending on the functional requirement, you have to discuss with the client, and then you have to decide on the structural system. Once you decide on the structural system, then it is modeling and analysis. So you have to do the trial sections and then model it and do the analysis. Once you do the analysis, you know what are the forces or the stresses acting on that. Based on that, you proportion the member and design the member. If it is acceptable, that member design, then you can go in for the connection design. If it is not acceptable, you have to revise the section and then model it again. So this process is an iterative process, and then you finally come to a section which is acceptable, and then you design the connection and then detail it and the final design and then the drawings. Then it goes to the site. This is the process which is happening in the design. Okay. Now, I want you to think before finalizing any member these aspects. Is the deflected shape consistent with what was expected? For example, if it is a simply supported beam, you expect it to bend downwards. Okay. Is that deflected shape you are getting in the analysis? You have to check. It is a must. Okay. You have to check that. And is the beam depth consistent with the standard rules of thumb. There are certain thumb rules which you will be studying in the current semester, like IS 456 gives some thumb rules, like if it is a beam, simply supported beam, the depth should be L by 20. So such rules are available. Based on that thumb rules, the depth is consistent. You have to check. Do connection details match the assumptions used in the analysis? Because you do an assumption like the beam is a fixed beam. Then you have to detail it in such a way that the end condition is a fixed condition. You cannot assume a fixed condition and then detail a simply supported beam. Then it will fail. So this also you have to check. And are the primary structural member sizes similar to members in similar projects? So you can check the member sizing with similar projects with the same span, same loading condition. It may not be possible always, but if it is possible, it is better to check. Two beams deflect more than permitted. The code specifies allowable deflection. So you have to check for that deflection also. These are called serviceability condition. This is most important. Okay. Intuitively and instinctively, would you want to walk under it, live above it, and climb on it? Okay. You have designed a structure. You will be willing to walk under it, live above it, and climb on it. Very important. Okay. So the topics I've covered in this session is review of the provision of safety, consequences on uncertainties of loading and material properties, the design process, and the structural system. Finally, I just want to tell you the former USA president, who is a mining engineer, who said the great liability of the engineer, okay, compared to men of other professions, is that his works are out in the open. People can, especially for civil engineers, people can see it, criticize it, appreciate it. Okay. So he cannot bury his mistakes. The engineer cannot bury his mistakes like the doctors. He cannot argue them into thin air like what lawyers do. He cannot, like the architect, cover these figures with trees and vines. And he cannot, like the politicians, screen his shortcomings and then blame others for his mistakes. And the engineer simply cannot deny his actions. Okay. So with that, I conclude.